Before we get into today's lesson, I'd like to discuss or rehash a few things from yesterday. So we were talking about interference, and in particular at these points B, A through G, but in particular we're going to look at B. So what we're going to be talking about here are the distances the wave took to get to B from S1, from source 1, and from source 2. So if I look at this in terms of wavelength, I have 1, 2, 3, 4, 5 wavelengths from source 1. And then again, if I look to get constructive interference from source 2, when I look at this, I have 1, 2, 3, 4, 5, 6 wavelengths. Now, anytime you have constructive interference, the path difference between S1 and S2, essentially D2 minus D1, in that case, the absolute value of it is going to be a whole number of wavelengths, which is going to be important and relevant in the derivation in a little bit, but needs to be highlighted again here. So another key difference or another key aspect of this is if I look at all the points of interference, which I will highlight along here. So if I look at this point here, and this point here, this point here, and here, where you have all the crests and all the troughs interfering, basically till we get back to where we were originally. All those points highlighted in blue. Anytime you look at the path difference of S1 to S2, S2 always has to travel in one extra wavelength to interfere. Just for a quick example to show you this, if I pick this point here, I would have 1, 2, 3 wavelengths from S2, and then 1, 2 wavelengths from S1. So D1 would be 2 wavelengths, and then the distance for 2, which I drew in blue, but I'm writing here in red, is 3 wavelengths. Again, ultimately D2 minus D1 will give you 1 wavelength, and you will have constructive interference. So all along those circles that we drew yesterday, those lines going back to close to the distance between S1 and S2 is ultimately going to equal